This is the second of 2 videos for the topic, Writing and Evaluating a Function Modeling Continuous Exponential Growth or Decay Given Doubling Time or Half-Life. This video will focus on continuous exponential growth, which is often used for population growth of anything from humans to bacteria, as these organisms are constantly reproducing. For this, you will sometimes be asked to find the doubling time of the growth. For population growth, this would mean the amount of time it takes for the population to double. You may have seen the general formula for continuous exponential growth or decay from the first video for this topic. We will work through an example on continuous exponential growth, which occurs when the rate is positive. The area covered by a population of bacteria increases according to a continuous exponential growth model. If a sample culture covers an area of 53.2 square millimeters and has a known doubling time of 10 hours, what is the formula that relates y to t? Let's summarize our problem. We know that, initially, the culture covers an area of 53.2 square millimeters. The doubling time for this specific bacteria was given to be 10 hours. Using your knowledge of doubling time, how much area will the bacteria cover after 10 hours?
I think the area should double in 10 hours, so 106.4 square millimeters.
Great work! If we use 10 hours as our time, 53.2 square millimeters as the initial area, and 106.4 square millimeters as the final area, we can solve for the rate. Can you substitute these values into the general formula and solve for r?
Sure, I'll give it a try. 106.4 equals 53.2 times e raised to the r times 10. I divide both sides by 53.2 and write 2 equals e raised to the 10r. Now I will take the natural log of both sides. Natural log of 2 equals natural log of e raised to the 10r. And simplify the right side. Natural log of 2 equals 10r times natural log of e. Because natural log of e equals 1, I can rewrite the equation like this. Natural log of 2 equals 10r times 1. And that means natural log of 2 equals 10r. Now we divide both sides by 10. Natural log of 2 divided by 10 equals 10r divided by 10. And we get r equals natural log of 2 divided by 10.
Excellent work! What questions do you have?
In the last video, the shortcut for determining the rate for half-life was r equals natural log of 0.5 divided by t. Would it be r equals natural log of 2 divided by t for doubling time?
Yes, you are absolutely correct. Now, to complete the example, we will substitute r and y naught into the general formula and write y equals 53.2 e raised to the natural log of 2 divided by 10 times t. Like in the last video, you can now use this formula to determine the final area the bacteria covers at any point in time. For example, if we wanted to determine the area covered by the bacteria after 48 hours, we would substitute 48 for t and get about 1,482 square millimeters at the end of 48 hours.